focus. Boom. All right. If 4.3 was super important, 4.4 is super duper important. 4.3 had the theorems, right? The implications. It had the fundamental theorem of calculus, parts 1 and 2, and it had the mean value theorem for integrals, which is the average value theorem. 4.4 now is all about practice. It's the practicing part. It's actually evaluating things, okay? Integration by u-substitution, which I've kind of shown you a little bit of that, or pattern recognition. Now, pattern recognition is going to be a fast way to do it, but you don't recognize patterns until you do what? You repeat it, right? If you put it in enough mental sweat and mental equity, you'll be able to cash in on that because you'll recognize the patterns. So here we go. Example 1. The derivative with respect to x of tangent of e to the 4x squared. Wow. If we were to take the derivative like we're fixing to here in Texas, what rule would we use? We have power rule, product rule, quotient rule, chain rule, implicit. Chain rule, right? This is the chain rule. The chain rule, remember, is for embedded functions. Embedded functions. We have a function inside of a function. And remember, we call anything that's other than the independent variable, in this case, x, anything that's other than plain old x, we call an inside function. It could be as simple as 4x, or it could be as, challenging as like, whatever, 5x squared, or something, sine of x, whatever. So let's count the layers, right? We counted the layers, and the number of layers that we saw is the number of factors that we had in our answer. You walk up from the outside, it's what's up tangent of blob, so that's the outside layer. You come in and you got e to the blob, so that's your second layer. And then in the exponent, you have the 4x squared. So how many layers? Three layers, okay? We don't need to color code them, but I will, right? You got the outer layer tangent, and then the next layer inside would be the e layer. And then the innermost layer is 4x squared. So with 3 factors, or three embedded functions, 3 layers, we're gonna have 3 factors. And working from the outside in, right? What's the derivative of tangent of blob? Secant squared of the same blob, right? The same blob. Times, there's that multiplication symbol, times. Now we go inside and we're like, what's up, E? What's the derivative of e to the blob? E to the blob, right? Times the natural log of E, if you want to mentally think about that. But the natural log of E is 1. So it's the only one that's truly its own grandpa. And then times the innermost blob, which in this case is 4x squared. The derivative of 4x squared is 8x. Okay. So again, you could think of the chain rule as unpacking boxes is another way to think about it, right? You got your big outer box tangent, and inside that box, you have another box E, and inside that box, you have smaller boxes yet, right? This is not uncommon. Like at Christmas, I go and I get the big box, which is the red one. Inside there, I have a couple of other smaller boxes that have like homemade ornaments versus Hallmark ornaments versus math ornaments that I've kept that people have contributed for bonus points and hung on the trees in the hallway over the years, right? Those are all in boxes. Inside one of those boxes, namely the Hallmark boxes, you have a bunch of tiny little Hallmark boxes, right? So you do have boxes within boxes. And at the end of the year, at the end of the Christmas season, which is usually kind of around when the 3 kings reach the manger, we got to put them all back in, right? So now I look at I put the little ornaments into the Hallmark boxes, and then I put the Hallmark boxes back into that medium-sized box. Finally, I put all those bigger boxes into the giant container, and I lug it upstairs to my giant attic, which is not a pull down. Luckily, it's just a regular steps. That's what we're going to do on the next step. I'm not going to clean this up, but normally what we would do is we would put the 2 factors that we unpacked on the right hand side. When we rewrote it, we would put them into the front, right? Okay. Any questions on that? That's pretty easy, right? Unpack those boxes one at a time, and you multiply them. Well, look at example 2. Evaluate the indefinite integral. How do we know this is an indefinite integral? There's no, what do we call those? Intervals of Integration. There's no lower bound, there's no upper bound. So, and it's all with respect to x. So we got our left bookend, we got our right bookend, and let's see. It's 8x times e to the 4x squared times secant squared of e to the 4x squared. Is there a product rule for anti-differentiation? No. Is there a quotient rule? No. Really, the only rule that we have for anti-differentiating is the power rule. If it's a single thing, you know, ax to the n, we add 1 divided by the new exponent. So if there's no product rule for anti-differentiation, what are we going to do? Well, we have to recognize this as an unpacked chain rule. Okay, we have to recognize it as an unpacked chain rule. Now we know the answer to this, don't we? Because I just gave you the problem in reverse. So what would the antiderivative be? I'm going to write it out here to the right. It would be tangent of e to the 4x squared plus c. We would add a plus c because there might have been a constant there, right? Now here's the deal. When we have a problem like example 2, it's not always going to be preceded by a question like example 1, is it? So how are we going to recognize that it does get packaged back up into there? Well, first of all, your first hint is it's a product. There is no product rule for integration. So if you have a product of variable functions, okay, this works well if you have a product or a quotient of variable functions. If it's just a constant multiple, like it's just the 8, we can pull the 8 out front, right? That's not a big deal. But if it's a variable function, like x or sine of x, there's no product quotient rule. This is where we have to look for the biggest box that's there in our factor groups and decide, hey, everything's got to go back into there. So that's your first step. Once you realize it's a product, which of these factors that are separated by dots is the biggest factor, is the bulkiest factor, is the ugliest looking factor that has the most information? The secant squared. Yeah. So let me highlight that. So this is your big box, secant squared of blob. That's your big box. Okay. That means the other little pieces must have been unpacked from there. And all you got to do is check. This is pattern recognition. This is going to check. Where did the 8x possibly come from? Oh, from the derivative of 4x squared. And where did the e to the 4x squared come from? It came from the derivative of e to the 4x squared. So essentially, this is kind of, if you want to visualize it, we're going to take this 8x and we're going to package it back up into this box. Okay. And now it's packaged back up. And then we're going to take this box and we're going to package it back up into the secant squared. See that? And now if I package those back up, I'm staring at secant squared. There can only be one big box, okay? And the big box is going to involve the integration, okay? This is what you integrate or anti-differentiate. It's the only thing you take the antiderivative of. The other stuff you actually take the derivative of to see if it's generated from there, okay? So 8x goes perfectly back into here because the derivative of 4x squared is 8x. Boom, we're not off by anything. E to the 4x squared gets packaged back up into e to the 4x squared perfectly because it is its own derivative. So now here we go. Now we're staring at secant squared of blob. Everything is packaged back up. Now it's time to package back up the big box. This would be closing it up, taping it, and making my way towards my giant attic. What is the antiderivative of secant squared of blob? Tangent of the blob, right? Plus c. Okay. All but one variable factor in your product or quotient have to be derivatives of what's inside of the other one. Okay. All of your factors but the big box itself have to be derivatives of the big box's contents or only off by a constant multiple. Should we write that? Let's write that. Because this is how you recognize pattern. You know what to look for, okay? All factors, whether they're multiplied or divided, except the big box factor, must be derivatives of the big box's contents. I put Bix box, right? Of the big box's contents. There you go. And I'm going to put in parentheses here, or only off by a constant. Because we know if we're off by a constant multiple, we could fix that by putting its reciprocal there, right? That's the antacid for the hot enchiladas that we're eating, the heating plate of enchiladas. But if you're off by a variable, that's not good. You can't be off by a variable, okay? So this right here gives you now the pattern to look for. Now, again, the nicest thing about anti-differentiating or integrating is you can check, right? Guess, check, revise. Guess, check, revise. If I'm not sure if this is right, or if I want to see if it's right, I can now take the derivative of this, which would give me example 1, right? And at that point, if I'm only off by a constant multiple, let's say, oh, my derivative gives me an unwanted 7, then I can come back and revise my original answer and put a 1/7 in the front, right? Reciprocals of unwanted constants. You look like a gunslinger now, baby.
Thank you.
Yeah. Okay. So that's the nice thing. You can always check. Guess, check, revise. Guess, check, revise. Guess, check, revise. Now, I'm starting you off with the very complicated one. Why is it complicated? Because it has 2 other variable factors that came from the inside function, okay? Normally, we're just going to have 1, okay? The big box contents, let me go ahead and give that a name. The big box's contents, I should move this so I can write below it. There you go. The big box's contents we call the inside function. Okay, inside function versus the big box itself. This is the outside function. And there could be only 1. Inside functions, you can have more than 1. Yes, sir.
The inside function is like
E to the 4x squared. Yes. E to the 4x squared is the inside function. Secant squared is the outside function. Very good. That's exactly right. Now, as we start going through these examples, it's going to start making more sense to you, because now that we know the idea and kind of what to look for, we're going to work ones that are a little bit easier. But we're not going to have the answer before we even start, like we did for example 2. Okay. So I'm teaching you by pattern recognition to start with. Blah, 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 blah. You can read that if you want. Blah, 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 blah. Okay. Example 3, right? You walk up to the problem and you're like, oh, evaluate the indefinite integral of x squared plus 1 to the 12th power times 2x with respect to x. It's all one term. That's okay. But I have 2 variable factors, right? 2 variable factors. Now, there is no product rule. There is no product rule. So I need to do either this. A, I can expand out x plus 1 to the 12th. Anyone want to do that? No, because it's not going to be easy, right? It's going to have 13 terms. And then you can distribute the 2x. And then you can go boom, 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 boom down the line. If you have an exponent like that that's prohibitive, that's not the way to do it. So which of those 2 factors is the bigger, bulkier of the 2? The first one, blob squared. The outside function is pretty easy to recognize, because imagine you're just walking up to it, right? What's up, blob squared? What's up, blob squared? This is your outside function, your big box. Okay. And if that's the outside function, then guess what must be the inside function? What's inside of it? X squared plus 1. And that's more than a plain old x. Okay. So here's all you have to do. Here's all you have to do. Let's check. This is a question you ask yourself. Did 2x, which is the other factor, did it come from the derivative of x squared plus 1? The inside factor. Well, let me instead of say x squared, let's say, did it come from the derivative of the inside function? That would be in general, which of course is x squared plus 1. Yeah, and you can do that in your head, right? Just real quickly. What's the derivative of x squared plus 1? 2x. Hey, that's exactly where the 2x came from. We're not even off by a constant. So we're ready to start packing things up, right? Holiday season's over. So this 2x gets packaged back up inside. And this is the hardest part for people to get straight in their head. They're like, where does it go? Well, we put it back in the big box, right? So it's gone. Just like when we take the derivative by unpacking it, it appears out of the big box. All right. So 2x is back in the inside the big box, and there's no correction to make. So now we move on to the second step. Okay. What's the outside function? Well, it's blob to the 12th. How would we integrate blob to the 12th? If it were just a single variable, if this were u to the 12th, which is what u-substitution does. It takes that and replaces it with a single letter. What would the antiderivative of u to the 12th be? Using the power rule, it's the one rule we have, right? U to the 13th, and then divide by 13 and multiply by 1/13 plus c. Well, guess what goes inside the box? Instead of u, we'll actually put what? X squared plus 1. Yeah, and there it is. In other words, pattern recognition is really doing u-substitution in your head. Is that right? Yeah, you know how we know it's right? No, I didn't tell you. I think I did, right? I can't take that back. But we could check for ourselves, right, Zachariah? We could take the derivative. Let's take the derivative using the chain rule in our head mentally. 13 times the third is 1, is gone, good, times blob to the 12th. Gotti, right? Times the chain rule, the derivative of x squared plus 1, which is 2x, plus the derivative of c is what? 0. Did we do it? We did it. Now, if you're ever off by a constant multiple, that's it. Go back on your revision and put the reciprocal of that unwanted number in front. It's that easy. Okay. So that one was a little bit better because we didn't take the derivative to start with. But it was still a little too easy because the derivative of the inside function was exclusively the other factor, right? Calm down, Juwan Howard. Did y'all see that over the weekend? Michigan basketball coach slapped one of the Wisconsin assistant coaches. Yeah, Tech plays tonight. He's done for the year. Yeah. Okay, let's try out example 4. Okay, all right. Evaluate 3x squared, 3x cubed sine of 2. Okay, first of all, it's a product of two variable functions. That's the first thing that you need to figure out. Is there a product rule now for integration? No. Now, as a general method of housekeeping, if you ever see a constant multiple, it's better just to pull it out front, okay? Even if it works okay. Let's hold off on that because we haven't done that. Which of these two factors then, 3x cubed and sine of blob, look more complicated? The sine of blob. So let's see if it works. The outside function then should be sine of blob, right? It's easy to find the outside function. There can only be one. And then everything on the inside, whether it's one function or two, could potentially be the inside function. I'll put inside question mark because we have to check. When someone unpacked that box, is that what generated the 3x cubed? Well, let's see. What is the derivative of 2x to the 4th plus 1? 8x cubed. Ay, caramba. It's supposed to be 3x cubed. Is that a problem though? If we're only off by a constant multiple? Not at all. Never. The important part is, did I generate the variable factor part? And I did. I got an x cubed. So I know I have it. I've identified it. So here's what I would recommend you do every time. Bless you. It's like it sneezes, I think. In this case, the 2x was, the factor was written second instead of first like it normally was. Like it was supposed to be there to help us with something, you know? But normally it's going to be in the front, like on example 4, sorry. So here's what I would do. Step 1, tidy it up. Bring the 3 into the front, put it as x cubed, and maybe put parentheses around it. And then you got sine of parentheses, 2x to the 4th plus 1. Maybe we don't need those, the big parentheses. There we go. In other words, this is your housekeeping step. Constant multiples out front. And then as you go through, you can rewrite any square roots or radicals as rational exponents. And if you have anything like in condensed form, like sine squared of x, you would write it as sine of x quantity squared, possibly. It's your housekeeping step, all right? Now watch this. 3 is already in the answer. 3 is already in the answer. He's just a writer. He's writing his way through the problem. Hey, what are you guys doing up there? Shut up. Shut up. There's a raspa for you at the end. And now we could say, oh, what's the inside function? 2x to the 4th plus 1. Let's check. What's its derivative? Its derivative is 8x cubed. Did we get the x cubed part? That's the critical part. Yes, we did. We got the x cubed part. Bingo. We're only off by an 8. We're off by an 8 factor. If you're only off by a number factor, no problemo. We're eating the cheese enchiladas that are hot and steamy, like the Robert Earl Keen song. All we got to do is put the antacid in front, which is what? 1/8. This is our correction. Once you get your correction taken care of, you're ready to move on to the big box, okay? You're ready to move on to the big box. What's the big box? It's sine, right? Sine of blob. Ooh, I'm not using the highlighter. It's sine of blob. So what's the antiderivative of sine of blob? Negative cosine of the blob. No, where did the x cubed go? It got packaged back up, right? That's the thing that people are like, where did it go? It got packaged up, right? Just like when we were taking the derivative of this, Lauren, where did this e to the 4x squared came out of nowhere? Yeah, but we were unpacking the box. Where did the 8x come from? It came out of nowhere. We unpacked the box. So if we were going in reverse, this would go into here, it's gone. This would go into here, it's gone. Okay. I'll show you another way to do this one, but I want you to recognize the pattern because it's World Thinking Day, right? Yes, it is. Okay. So this is this and then plus C. This would be my guess. Okay. Now, what would you do if you were unsure? You could check it, right? Guess, check, take the derivative, and then revise. If you revise, no problem. Just put a reciprocal of an unwanted constant in front. That's all you can do on your revision. Sometimes you might have the wrong rule and you have to go back and kind of start from scratch. But look at the 3 constants that I have here. This is the most you'll ever have. These are the most you'll ever have. Let's label what they are because I give them names. The 3 is what I call the rider. Pull him out front. He's there in the beginning. He's going to be there in the end. Times, where did the 1/8 come from? This was our antacid, right? Correction. If you want to call it antacid, you can. It's not anti-acid, it's just antacid, right? Antacid, that's like formic acid is antacid, right? That's what they make. And then what is this negative? We could just call that the rule. Okay, like when you do the power rule, you add 1 and multiply by its reciprocal. That's part of the rule. Those are the 3 types of constant multiples you'll have in the front. You may not have any of them, but at most, this is the most you have. Okay, and this is in the unadulterated form. They're still standing proud separately on their own from where they came or from whence they came, right? And now all we have to do to make our answer more stylized is combine them, yes? So this gives us -3/8 cosine of 2x to the fourth plus 1 plus c. Now let's see about notation. If you were doing this on a free response and you didn't put your plus c on the line above, because you're like, I know this isn't my final answer, I'm just kind of working on the main part, I'm just, I know I'm just working. And then you come down here and put plus c, are you going to get full credit? No, because you're working straight down in your project. That's your project. That's your presentation. It has to be correct at every single line. If you want to go off to the side on your mathematical workbench and do some scribble thinking, that's where you do it. But you don't do it in the flow of your project, okay? That plus c has to appear immediately on the anti-differentiation step and then everywhere after that, okay? So on a free response, you would stop on the line above in red. On a multiple choice, you would have to pick this out of a lineup, right? And of course, it could be this, when we're dividing by 8, it could also be the first term, right? Or -3 cosine of 2x to the fourth plus 1, all divided by 8 plus c. Okay. That would just be that first term. But remember, c is the ShamWow c. It absorbs a lot of constants a long way to the answer. Okay, now, question here. Let's say we're doing this and we get to the guess line. What if I leave off these parentheses? Is that okay? My 3 goes along for the ride. I'm off by an 8, so I put a 1/8 correction. What's the antiderivative sign? Negative cosine. Okay. If I write it like this, I got the right answer on the purple line, didn't I? You would still lose a check up here. We call this a recovery. You're lying up here, but you recovered and have the right answer here. So why would you lie up here just to tell us the truth right here? Go back and fix your lie, right? You turn this into a subtraction problem. So how could you circumvent that or get around that? Well, 2 ways, right? Bless you. You either put it in parentheses as you write it down, or, and I didn't do it this way because I wanted to show you the method, or you could just bring the negative out front, bless you, to begin with, right? Oh, I took the cosine with it. Oops. You could just bring the negative out front to begin with, and now you have that awkward space. That's fine. The coefficients in front are there for you. Okay, you can put them in any order you want, but if it comes on the interior, you better make sure that you have parentheses around that. Don't put dot negative either, right? Some people are like, I don't want to put the parentheses, but if I put a dot there, dot negative, what are you speaking Morse code? SOS, right? Dash and da. You're going to make me growl like Papa Bear, right? Get out, Goldilocks. Get out, Goldilocks. No, don't ever put dot negative. Okay. I know, right? How is that? Fun? Yeah. Now, let me show you the other way. This is called u-substitution. Formal u-substitution. We'll do this in the last 4 minutes. We still have the same problem. Yes? I'm going to say, okay, 3, you get to the front. Get in the front of the integral. Just go along for the ride. Okay, so my first step is still to go through and rewrite it and take inventory and do all that other stuff. dx, don't leave off the dx. But it's a little more of a formal idea. You still have to identify the inside function, which is that. So now you go off to the side and you declare this. Let u, bless you, equal 2x to the fourth plus 1. It's a dummy variable. It's just a temporary placeholder for a function of x. It's a single letter that replaces a function of x, regardless of how complicated it looks, okay? Now, as we did the other day, your goal is to rewrite everything over here that has an x in it to write it equivalently in terms of u. And what I do is I just do it as I get it. So my first thing is to write this now as sine of not 2x to the fourth plus 1, but sine of, no, just u. No, I'm calling the whole thing u. Yeah. So that becomes sine of u. So I got that one checked off. What else do I have to do? I need to get rid of the x cubed, and I need to get rid of the dx. Now, because we're always going to have to get rid of the dx, that means we're going to need the derivative. So let's take the derivative. You can either take the derivative of u with respect to x, which I think you're more comfortable with, Leibniz notation, 8x cubed, right? And now we can multiply both sides by dx. du equals 8x cubed dx. Or you can go straight to here, right? This line here is called differential form. We talked about it in 3.7. But it doesn't matter how many steps you take, as long as you're successful, right? And the time doesn't run out on you, right? Okay. And so now let's see. I want to get rid of the x cubed and the dx. Well, boy howdy, as we sometimes say in the Wild West. Look at this. I got an x cubed and a dx both right there. So instead of just solving this for dx, let me go ahead and solve that for x cubed dx. So I know that x cubed dx, if I divide both sides by 8 or multiply both sides by 1/8, I get 1/8 du. Well, hot diggity donut. Look at there. I can replace both of them fellas with just a single 1/8 du. 1/8 du. That takes care of this one and this one, all in one step. Man, don't that beautiful? Don't that beautiful? I mean, man, I woke up today in my lucky day. Look at there. Okay. So now I put it all in terms of u. Let's kind of re-clean it up. That 1/8 that's in front of the du, you get out in front with the 3, right? You'll clean out the back of my truck. Get rid of all them soda cans back there. Sine of u du. Wow. So here's what u-substitution does. It gets rid of the composition part of it. And now remember, because it's sine of u with respect to u, at that point, it might as well be like sine of p with respect to p, or sine of q with respect to q, or sine of x with respect to x. What's the antiderivative of sine of u with respect to u? The antiderivative? Negative cosine of u plus c. I ain't forgetting the plus c. Now look at this, dot negative, dot negative. Nope, I'm going to do this. All right. So now I'm going to clean it up. That does become -8, -3/8 cosine. And guess what? U was just a temporary placeholder. I got to substitute it back in. What is U? U is 2x to the 4th plus 1 plus c. And loisimos, as we say on the Dora the Explorer show. Loisimos, we did it. We did it. Yeah. Does it matter which way you do it? No. No. You do need to know how to use formal u-substitution, because they've been kind of on to teachers now that are just teaching the pattern recognition. And now they write multiple choice questions where it says, if the substitution of u equals this is made, what's your new integral? And the answer ends up being this. You have choices that are answer choices. Now, there will be later on, when we get to the end of this section, there will be a time where you have to use u-substitution to integrate. But right now, if you just check and your inside function generates all the other factors and you're only off by a constant multiple, you can use pattern recognition. Okay? Yes. Oh, okay. Isn't this fantastic? It's fun. It's like Sudoku and crosswords all in one, and Wordle. Speaking of Wordle, where has Bendelay been?
He's at a stock show.
Where? Oh, Quero. Oh, I thought you were gonna say he was like running or burning. What's the Burning Man? He's at a stock show. Okay, he's showing. Okay. Any comments or questions on this? We are gonna pick up the pace mañana. You'll have 5 questions again tonight that are due Thursday. I'll put them due Thursday at the end of advisory. Okay. So you always have that last advisory to work on them. Is that okay? Ella, is that okay? You look tired or you're angry with me? Either one. You're just tired? Oh, you're just angry with me. Okay. All right. Yeah. All right. You can leave the props behind. Thank you for getting them with me. Thank you for testing them out. Tomorrow night's going to be a blast. Yeah.